In this video, we are going to take our pattern recognition skills to the next level. Are you ready? I'm ready. Let's do this. So we are given two sequences in this first part of the video. I'm going to hit a second part of the video where we do two more sequences. Our goal is going to be to get good at the process of writing rules for a sequence of numbers. Now, this is a little bit more difficult. Some people won't even have to do this in their math careers, but I would hope that most of us are learning this somewhere along the lines. It's going to help us to understand why all kinds of algebra works the way that it does down the road. So, without any further ado, our goal is to figure out some rule that will allow us to plug in the term numbers into this rule to give us back these terms in the sequence. And if you're listening to this saying term numbers, what's he talking about? You're going to want to watch a previous video where I go over what a sequence is and what terms are and how to plug numbers into those sequence rules. Otherwise, you're probably listening to this being like, wow, this is gibberish. Okay, so what I like to do is I like to look at the numbers and sometimes organize it in a table, sometimes not. I'm going to organize it in a table for you. And I like to look at the differences between the numbers in my pattern or in my sequence. So I look here and I see that the difference is 7 between each number. Well, let's kind of write this out in a table. So if I've got a table where I've got my nth term, right? So n is the term number. This is the first term, second term, third term, fourth term. So I'll have the first term is 7. And so this is the term itself. So that's the number term that we're at, and that's the term itself. The second term is 14. The third term is 21. And the fourth term is 28. Now, some people will just look at this and say, I got the pattern. I know what we do to n, these numbers, to get the term number. And if you can describe that, then you're good to go. If not, I think my system will help you. So some people will look at this again right away, have the answer, and that's okay if you don't. So for each n value, it looks like we go up by 1. That's the pattern over here. So you want to determine how much we go up by on that n side. Then the output, or the resulting term we get, is going to be, well, it looks like there's a pattern of adding 7 as those results happen. So I add 7 to get to each next term, right? I go up by 7. So let's think about this out loud now. For every one more we go in the n column, one more, we go 7 more in the term column. So that sounds like we have 7 times the amount that we have in the term column than we have compared in the n column. So if I'm repeatedly adding by 7, another way of looking at this, repeatedly adding by 7, for every one n we go up, I'm multiplying n by 7. Isn't that cool? So for each n term up 1, we go up 7 repeatedly. That's 7 times the n term. And that's it. So that, folks, is your rule for the sequence. How do you check your answer? Well, you literally take the term number and plug them in, and we should get that numbered term out. So if I plug in 7 times 1, yep, my first term is 7, and then do 7 times 2. Yep, my second term is indeed 14. Sweet. I do the third term, 7 times 3, and that's going to be 21, the third term. And finally, 7 times 4, that's going to be 28. We have found ourselves a rule that works, 7 times the numbered term. It's not easy to necessarily come up with. Some people, though, will look at this and just ask themselves the question, what do I do to the n value to get the term value? I multiply each of these by 7. 7n. Done. And that's cool, too. And you're lucky if you get it that way. That's pretty sweet. All right, let's go on to a second sequence before we flip into a later part of the video where I will give you bonus coverage of 2 more sequences. So in this one, I'm going to do this with, again, a table just to organize our thoughts. You don't have to make a table, but I think tables help to organize n and the term number. The first term is -8. So that's 1, -8. The second term is -7, so 2 corresponds with -7. The third term is -6, 3, -6. And the fourth term is 4, -5. All right, so we have that. Now, since we have those 4 terms, let's again, like we did over here, look at the pattern between the n values. Well, the n values, no surprise, they're going to go up by 1 each time. What's happening with the term values? Well, to go from -8 to -7, be careful here, we're actually going up 1. So we go up 1 each time, and then again, negative 7 plus 1 is negative 6. Negative 6 plus 1 is negative 5. Now, here, for every 1n term, we go up 1, which would just be multiplying this by 1, seemingly, right? So we start out with n. Now, in the last problem, when we tested our values, we got the terms back that we wanted. The reason why I'm just putting n is you're literally multiplying. For every 1 term, we get 1n, or 1n term, we get 1 term out. So we're multiplying by 1. There's a problem here. When I go to plug in my term number, I just get 1. Right? That's what happens when I evaluate for n. But I want negative 8. How do we get to negative 8? Well, if I were to plug in 2, I would just get 2. And I want negative 7. Ooh. Well, what could we manipulate? What could we do to the 1 to get to negative 8? Well, 1 and negative 8 are 9 away. If I were to subtract 9, I would get negative 8. Let's try that same manipulation with the 2. 2 minus 9 is, negative 7. 3 minus 9 is negative 6. We're getting there. And 4 minus 5 is negative 5. So we get our terms, but only if we take the nth term and subtract 9. So in this case, we had to use a little bit of detective work where we said, well, it's a 1-to-1 relationship, so I'm just getting whatever nth term there is. But then when we plugged in our numbers to test and see if it worked, we realized, no, it doesn't work. We're off by minus 9 each time. So I'll subtract 9 from each, and that wiggled ourselves to the answer for the rule for that sequence. All right, very cool. Stay tuned. I've got more sequence examples for you on the other side of this video. And here we are on the other side of finding rules for sequences. I've got 2 more examples for you. So if you're having a little bit more trouble with this, I've given you a little bit more variety to help you out. This tends to be one of the harder topics that people, well, come across in their early math studies, especially in their early algebra studies. Okay, on to this problem. We've got negative 5, negative 10, negative 15, negative 20. We need a rule. So again, I like to organize this in a table. It helps to just kind of get a pattern of what's going on. I've got the nth term, and then I've got the actual term values. So I've got my first term, second term, third term, and fourth term here. My first term is negative 5. My second term is negative 10. Then negative 15 and negative 20. And you might look at this and say, I already know the pattern. Then you're in really good shape. But for those of us that aren't seeing it right away, let's go over this technique. So again, I'm going up by 1 every time that I go up in the n direction. And that's normal. In a sequence, you go up by 1. First term, second term, third term, fourth term. However, on the right-hand side here, we are actually going down by 5. So you could look at that as subtraction of 5, or repeatedly adding a negative 5. Ooh, okay. If I'm repeatedly adding a negative 5, that means I'm repeatedly multiplying by a negative 5. Oh, you could take that and just kind of, I don't know, look at this and say, so for every 1 additional n I go up, I'm adding another negative 5. That's multiplying n by negative 5. And now let's try it. I'm going to do this one mentally. Earlier in the video, I was showing out every little step. Negative 5 times the first term. So times 1 is negative 5. Check. Negative 5 times the second term. Times 2 is negative 10. Check. Negative 5 times 3 is negative 15. Check. This looks good. Negative 5 times 4 is negative 20. Check. So we don't have to do any addition or subtraction to alter this to get that sequence. This is the rule for the sequence. Very cool stuff. All right, last but certainly not least, we have the sequence starting at 5, going up to 8, 11, and 14. So I'm going to do this one again. We'll stay consistent. We'll make a table. Our n terms, we have 4 terms, 1, 2, 3, and 4. The first term is 5. The second term is 11, my favorite number coincidentally, and you're probably thinking, oh, I don't care that that's his favorite number, but he should care that that's not the second term. The second term is 8. The third term is 11. I got so preoccupied and focused on how great 11 was, I put it in the wrong spot. Okay, so now we've got our n values, each of which continue to go up by 1 every time, and the terms are going up by 3. we add 3 to 5 to get 8, 3 to 8 to get 11, and 3 to 11 to get 14. So we're repeatedly adding 3 for every one n. 3 per n. That's multiplication of 3 times n. Oh, so let's check our work. Well, if I do 3 times 1, I get 3, and I want 5. Ugh. Well, what would I have to do to 3 to get to 5? Because when I plugged in 1, I got out 3, not 5. I'd have to add 2. Let's try doing that. Let's try making that tweak, adding 2 and seeing if that helps. It gets us the 5 we want. Let's see if it gets us the rest of our numbers. 3 times the second term plus now the 2 that we're doing is going to give us 8. 3 times 2 is 6 plus 2 is 8. 3 times 3 is 9 plus the 2 is 11. Yep, and this looks like it's good. 3 times 4 plus the 2 is going to give us 14, which is our sequences rule. So 3n plus 2 is our rule. A little bit of detective work. We saw that it was 3 times the number of term that we're at, but we needed to add a little something extra to get ourselves to the exact term. Sequences are very cool. It's not something you're going to do a lot of in your class specifically, like directly, but understanding patterns and how they work will help you a ton as you work through your math journey.